The last two topics that we're going to go through illustrate how you can use factors to compare two or more numbers. Now, it might seem that all we're doing right now is we're just using this as a way to give you more questions associated with factorizing, but the ability to get, first of all, the highest common factor of a group of numbers or the lowest common multiple of a group of numbers will come very much in handy as we're doing some more sophisticated mathematical processes. So anyway, highest common factor. Well, let's think what that's saying. You've got a group of numbers, okay, and you can factorize all of them, so you can figure out what all their factors are. And what you want is you want the highest number that goes into all of your groups of numbers. Okay, so the highest common factor is the biggest number that goes into all of them. So let's start off with a pair of numbers, 16 and 24. Can you come up with the biggest number that goes into all of them? Well, obviously, 1 goes into all of them. That's just stupid. 2 goes into both of them. Okay, 4 goes into both of them. 6 doesn't go into 16. 8 goes into both of them. 16 is 2 times 8. 24 is 3 times 8. Anything higher doesn't go into both of them. So therefore 8 is the highest common factor. Now I did that by inspection. However, a lot of times it's going to be tough for you to do it by inspection. So there's 2 other processes that we can go through. The most useful process is you factor each and then take the common factors of them. So 16, if we factorize it, it's 2 times 2 times 2 times 2. 24 is 2 times 2 times 2 times 3. What's common to both of those? Well, both of them have got 2 times 2 times 2. Okay, 16 has an extra 2, 24 has an extra 3, but because 24 doesn't have that fourth 2 and 16 doesn't have a 3, we eliminate those and we say that the common factors are the 2 times 2 times 2. What's 2 times 2 times 2? It is 8. Now there's a third way to do it called the Euclid method that I'm just going to put in just for interest's sake, really, because it's complicated and it's kind of like taking a sledgehammer to break a nut. But what the heck, let's throw in the Euclid method, which is essentially to take the 2 numbers that you've got. It only works to compare 2 numbers and you put them in square brackets just to help you organize them. And then you write another square bracket that's got the smaller of the 2 numbers and then the difference in them. So the smaller of these numbers is 16, so I'll put that in green, and the difference between 16 and 24 is 8, which I'll put in blue. So we take the numbers and now we go through and we just write the smaller and the difference in brackets. Now we're going to do that as often as we need to until they're the same. So what's the smaller number here? Well, it's 8, and what's the difference? Well, 16 minus 8 is 8. They're both the same, and at that point we say, oh, we've got the HCF, the highest common factor. This is one of those things I don't like, because what I'm doing here is I'm just throwing it out there and say, do it. Now, if I was really nasty, I would say demonstrate how the Euclid method works algebraically, but I'm not really nasty. I'm a nice person, so I'm not going to do that, right? I would prefer that we do the formal factorization, but if you want to play with the Euclid method, go ahead. I think it is worth doing another example. Find the highest common factor of 196 and 462. Now, I can't do that by inspection. Maybe we got some people in here who can look at that and do that, but I'm not even going to try. So I'm just going to go ahead and do the factorization. 196 is an even number. So let's divide that by 2 to get 98. That is also an even number. So let's divide that by 2 to get 49. Now 49 is not divided by 2. 4 plus 9 is 13, so it's not divided by 2. Doesn't end in 0 or 5, so it's not divisible by 5. Is it divisible by 7? Yes, it is, because 49 is divisible not just once by 7, but twice by 7 to get down to 1. So the factors of 196, 2 times 2 times 7 times 7. Now let's look at 462 again. It's even. Divide it by 2 to get 231. Now that's not even, so let's try dividing by 3. 2 plus 3 plus 1 is 6. 6 is divisible by 3, so that gives us 77. Now 77, not divisible by 2 or 3 or 5. I hope you can immediately tell it is divisible by 7, however, to give us 11. And now 11 is a prime number itself, so we'll just divide 11 by 11 to get 1. So the factors of 462, 2 times 3 times 7 times 11. Now, what are the common factors there? Well, they both got a 2 and they both got a 7. You don't have a second 2 in 462, you don't have a second 7 in 462, and you don't have a 3 or an 11 in 196. So the common factors are 2 and 7, thus the highest common factor is 14. Try this by the Euclid method and try not to fall asleep as I'm going through it. So I'll write the two numbers in square brackets, 196, 462. Next bracket will do the smaller and the difference. Well, the smaller is 196, and 462 minus 196 is 266. They're not the same. So let's write the smaller, 196, and the difference, which will be 70, in the next bracket. Now 70 becomes the smaller, and 196 minus 70 is 126. 70 is still the smaller. 126 minus 70 is 56. Now 56 is the smaller. 70 minus 56 is 14. Now 14 is the smaller. 56 minus 14 is 42. 14 is still the smaller. 42 minus 14 is 28. 14 is still the smaller, and 28 minus 14 is 14. There's the highest common factor. I leave it to you to determine which of those you want to do.